So duct insulation and sealing. Sealing, yung mga sa ducting, kailangan nyo ng insulation para ito. Ductwork insulation is applied to ductwork to minimize the rate of the thermal loss to the skinny sheet metal. Kasi malamig yung sa ducting mo, yung dinadaanan ng ducting mo is mainit. So magkakaroon ng heat loss doon. So ducts may also sweat when their surface temperature is below the dew point of the surrounding air. So magkakaroon ng condensation, so tutulo yung kisame mo. This can lead to water damage and microbial growth within the building. Yeah. A 15 degrees Fahrenheit temperature difference from the inside of the duct to the outside of the duct is considered the maximum difference allowed before insulation is necessary. So may dito na kaya. 1-inch thick fiberglass blanket, R value of 16, is almost always sufficient for thermal protection. So return air ducts only need to be insulated if they pass through environments that adversely affect the return air temperature. So normally yung supply lang. So sa return, so check yung temperature na kung more than 15, so kailangan mo ng insulation. So the insulation is joined by lapping it, stapling it, and taping it. Okay? A protective cover with vapor barriers such as an aluminum foil should be included in the insulation specification. Next is the ductwork air leakage. Duct leakage refers to the leakage of air from the air distribution system ductwork. The leakage can occur at joints, seams, and penetrations. This leakage causes two problems. One, some areas at the end of the run may be short of airflow, bawas na. And two, the fan energy increases as the cube of the air leakage increases. So for example, if a system has 10% leakage and the fan design was originally 20 horsepower, the new motor required to overcome the 10% loss will be 20 times 1.1 cube or 26.6 horsepower. So kailangan mo ng 26.6 horsepower or 30 horsepower to overcome the leakage. Kasi yung flow rate. In this case, the owner pays the equivalent of 6.6 horsepower in additional fan energy for the life of the building. Okay? So the air leakage can be represented as a function of the duct surface area, leakage class, and static pressure. Leakage class is determined by the construction method employed in duct fabrication in accordance with the ANSI SMACNA SBAC duct construction standards. So doon mo makikita kung ano yung classification ng leakage sa static pressure. So duct leakage test. So ductwork that is designed to operate at a static pressure in excess of 3 inches water column and is located outdoors shall be leak tested according to SMACNA SBAC Air Duct Leakage Test Manual. Hanapin niyo yung book na yan. So positive pressure leakage testing is acceptable for negative pressure ductworks. So the maximum permitted duct leakage shall be L maximum as in leakage is CL times P exponent 0.65, where L is the maximum permitted leakage in CFM per 100 square foot of duct surface area. So CL is the duct leakage class, CFM per 100 square foot of duct surface area at 1 inch water column. SMACNA has defined duct leakage rates as leakage class 24, 12, or 6. So these numbers simply mean that 1 inch of test pressure duct can be expected to leak 24, 12, or 6 CFM per square foot of duct surface. So P is the test pressure, which is equal to the design duct pressure class rating in inch water column based on ASTRE 90.1:6.4.4.2.2. Okay. So ductwork that is designed to operate at static pressure less than 3 inches water column and located outdoor or within unconditioned space shall be leak tested according to the testing procedure contained in SMACNA SBAC Air Duct Leakage Test Manual. So meron din siyang procedure para sa less than 3 inches. So itong mga terms na to, hanapin nyo dun sa SMACNA para maintindihan nyo. Yan, tinuturo tayo doon. Yun na kailangang i-discuss pa yun dito. So, duct, okay. Duct sealing. So, duct sealing is a process of applying approved materials or sealant on the duct joints prone to air leakages. So, location where sealing is typically performed include the supply and return plenums. The starting collars where duct are connected to the plenums, fittings in the ductworks, yung mga connection mo, splices within the duct, and terminations where the duct connect to the supply register. So, lahat yun. Approved sealant. Sealant should be UL181 listed, water-based, non-toxic, and water-resistant with high solid cement. Yung mga UL listed, ito yung mga tested, approved na gagamitin mo sa mga installation, construction. So marami yan sa ngayon. Hindi ka besting bubuo ng made in China na hindi UL listed. So mga gawa-gawa lang, so hindi pwede. Kailangan tested. Approved sealant are flexible gasket, fiber reinforced mastic, or mastic used with mesh tape. Duct systems sealed with mastic generally exhibit lower leakage. So mastic sealant utilized should be water-based, non-toxic, consists of at least 50% solid, and be UL181 approved. Ito yung mga materials na recommended. Foil tapes, cloth back tack tapes, or pressure-sensitive tapes are not suitable yung pang seal. So, oil-based caulking and glazing patterns should not be used. Sa pipe yata to. Both ASTRE and SMACNA standard specify the duct sealing requirements in terms of seal classes A, B, and C. So, ito yung seal classes or label. So, seal class A, yung mga requirements mo, is for all transverse joint and longitudinal seam and duct wall penetration. Transverse joints yung across, yung longitudinal yung sa length, yung sa haba ng duct. Pressure-sensitive tape shall not be used as the primary sealant. Seal Class B. All transverse joint and longitudinal seam. Pressure-sensitive tape shall not be used as the primary sealant. All transverse joints only. Yung Seal Class C. So, SBAC na SBAC ductwork seal classes. So, merong yung kanina is ASRE. Ito naman yung classes na sa SMAC na. C class A is from 2 to 5% total system leakage. All transverse joints, longitudinal seam, and duct penetration. C class B has 3 to 10% total system leakage. All transverse joints and longitudinal seam. C class C is 5 to 20% total system leakage. All transverse joints. Unsealed, which is 10 to 40% total system leakage. Ayan. Yan ang allowed. So, mag-allowance ka talaga. Sabi dito, 10% so magiging cube. Ano pala yun? So, yan yung mga leakage, sealing, insulation. So, hindi lang basta decide mo yung compute, so magbibigay ka ng allowance for the leakage. So, duct attenuation and noise consideration. So, sa rooms, meron tayong mga natawag noise criteria. So sa kwarto nyo, meron kang ducting, so meron siyang noise level na hindi ka maiingayan. Kasi kung hindi mo kontrolin, ay sa'yo, sa classroom din, ibalik ko lalo na sa classroom, kailangan may noise level ka sa ducting mo. Kasi makikipag-agawan yan sa ingay ng mga kaklase mo. Okay? So, the HVAC industry has established noise criteria NC values for evaluating the acceptability of sound levels. So, NC values for different types of building range from 30 to 40 decibel. A decibel is a unit of comparative sound measurement. A whispered conversation at a distance of 6 feet from the ear, for example, has a sound pressure level of 30 decibel. Yan. Whispered, 6 feet. Lapit na kaya. Tawagin mo lang, uy. Yan. So, may marinig lang kayo doon, that is 30 decibel. So, HVAC noise point. So, the figure sa left, sa right side, shows the noise point from a typical HVAC system. So, ito yung room. So, is the 1, 2, ito kasi yung return. So, mayroong mga points dyan na maingay. Kasi mayroong obstruction. So, dito naman, output. Yan. Ito elbow. So, may mga yung hangin mo, siyempre, natama. Okay. So, may noise effect yan. So, typical mechanical system noise component. Yan. So, the major source of the noise in air conditioning is due to the air velocity as well as the noise from fan. Sa fan is yung vibration. Ito naman sa ducting is velocity. The 5 distinct paths of noise are A. Ductborne noise, yung 1. It is caused by the flow of air and directly dependent of the velocity of air. Ito B. Radiated equipment noise. It is caused by the vibration of the equipment and inherent sound pressure of the equipment. C. Break-in noise. It is a radiated equipment noise that enters the ductwork and propagates down the sound system. C. Breakout noise. It transmits to the walls of the duct. Terminal noise, terminal end noise. It is caused by the airflows at the terminal devices such as diffuser or register. Okay. So, acoustical analysis of a ductwork system. So, noise due to air is roughly proportional to the peak power of the fan speed. If the speed of the fan is reduced by 10%, the decibel will be reduced by 2 decibel. If the fan speed is reduced by 20% and 30%, it will yield a noise reduction of 5 decibel and 8 decibel. So, respectively. So, yung testing and balancing, sa test balancing is yung mga ingay. Sa testing and balancing sa noise reduction kasama doon. Okay? Balansin mo yung mga equal yung flow rate mo. So, kung parang instrument, kailangan mo naman adjust para mag-equal siya. Tapos, siyempre, yung noise din, consider mo. Biglang nag-ingay, so doon ka sa blower, bababaan mo yung blower, tapos yung speed. So, pag binabaan mo yung speed, pan-speed, siyempre, bababa yung flow rate mo. So, dapat acceptable pa rin. So, based on the aforementioned analysis, the following recommendations are made. Ductborne noise. A. Keep air velocity low and liberally sized ducts. The air velocity in the main duct should be limited to 1,500 feet per minute, and the velocity through the branch duct should be less than 800 feet per minute. Kapag noise concern. B. Select the fan at maximum efficiency point. C. All BAB installation must have variable frequency drive. So BAB is a tandem topic. This is a variable air volume. D. Ductwork must be routed, fabricated, and supported in accordance with SMACNA guidelines. Yung mga hangers, hindi pwedeng masyadong mahaba ang distansya kasi magwe-wave siya. Radiated equipment noise. A. Use vibration isolators between the equipment and the building structure. Yan. Common materials used as a vibration isolator are rubber cork, various type of steel spring, and glass fiber fan. Yung mga equipment mo, huwag mo lang basta ipapatong sa sahig. Kailangan mo ng mga vibration isolator. So, use flexible fabric connection between the fan and duct. C. Avoid locating the HVAC unit in a space immediately adjacent to the occupied space. Mga machine room mo, katabi ng opisina mo. Tay. D. Acoustically insulate the mechanical room walls and ceiling with fiber insulation mounted on wooden battens. The insulation shall be clad with perforated aluminum sheet of 36 gauge. Manipis na yan. So, kung katabi yung room mo, so kailangan mo ng insulation. Acoustic insulation. Duct break-in and duct break-out. So, ensure low air velocity. The air velocity in the main duct branch should be limited to 1,500 feet per minute and 800 feet per minute respectively. Ay, pangit ng ano. Okay. Ensure ducts do not vibrate. Duct but can be made stiffer by adding external bracing and or adding damping spray on self-adhesive compounds. Kaya may mga stiffen na ng duct at may required thickness. C. Avoid abrupt changes in duct cross sections. Most straight ductwork naturally attenuates noise and provides smooth transitional duct runs, takeoffs, and bends. So, ibig sabihin ng avoid, minimize mo. Okay? So, hindi maiwasan. So, lalagyan mo ng liner. Beating, such as elbows and transition, should not be placed closer to 3 to 6 feet diameter downstream from a pan and duct transition, particularly at the unit inlet and discharge opening, 15 degrees maximum. Ito yan, di ba yung mga transition mo 15 degrees both sides, bagong bibiglain, dahil nga yung noise. E. Insulate the duct with rock wool or glass to damp duct breakout noise. Yan. F. So, use internal duct lining for so ito yung recommended, yung mga glass wool, nakakaano ng noise yan. Yung ibang insulation na. Okay? Kaya yung iba, binabalik nila sa fiberglass. F. Insulate. Use internal duct lining. Ito. For at least 10 to 15 feet from pan discharge. Yun. A 1-inch thick fiberglass duct insulation has an NRC of 0.7. This means it effectively absorbs 70% of the sound at most common frequencies. Kasi normally, nag-uumpisang ingay sa pan. Sa may mga mataas ang NC niyan. So, pag dito is, so, lagyan mo ng acoustic lining. So, 2-inch thick duct lining has an NRC of 90.9, absorbing 90% of the sound. So, caution, a 2-inch lining will reduce the cross-sectional area of the duct, causing an increase in velocity. This needs to be evaluated. So, since ang area mo required is inside area, so, yung outside mo ng duct is lalaki kasi yung ano mo, internal lining yan. Dapat ang inside mo is yung duct size mo talaga. Tapos, meron ka ng, tapos ng internal duct lining mo, then yung duct mo, duct sheet metal mo, then insulation naman. Okay? Lalaki. So, use flexible ducts only at the terminal ends of diffuser. The flexible duct should be completely stretched and restricted to 6 feet long, at least 1.2 meters. Diba? Required ng ano is 1.5 meters, but liliit. So, that is mga recommendations to. So, terminal noise. Install at least 3 diameter split bricks at the diffuser inlet or use a minimum of 6 feet of acoustical flex between the low pressure duct and the diffuser. B. Select diffuser grills and register for noise criteria rating of NC30 or lower for the design airflow rates. So, sa air conditioning natin, meron tong selection sa air distribution. Okay? So, also refer to SBAC application chapter, sound and vibration control as the handbook, chapter 43, 2003 edition for further reading, or plus 3, 2006, 2009. Check nyo kung equal siya. Okay? Regenerated noise. Medium and high velocity airflow impinging on any obstruction will cause disturbance of airflow. The resultant turbulence produces regenerated noise. So, HVAC duct design components such as elbows, turning beams, vanes, dampers, transition, offset, takeoffs, these, etc. are examples of such obstruction. The turbulence in most airflow systems is characterized by sharp changes in the airflow path, sharp bends, abrupt cross-sectional area changes, etc. In contrast to aerodynamic fan noise, which manifests itself in a more tonal frequency spectrum at the fan bay passes frequency. Turbulence and regenerated noise are generally characterized by a broadband frequency spectrum. So turbulence increases the noise level and system operating costs. So NC, so introduce to dun sa air conditioning. This noise criteria level. So wait. Regenerated noise can be minimized by ensuring smooth airflow conditions. Smart na duct design and construction guidelines should be incorporated in all job specifications and drawing. Specifications dun sa subject ng iba. The SMAC na guidelines also outline optimal duct silencer, locations, and guidelines for centrifugal fan installation. Distances for placement of duct fittings. Yan yung airflow, yan. Obstruction, andyan yung mga noise yan. So, daming topic sa mechanical, no? So, yan. Magko-concentrate lang sa iba. So, next is, hindi lang design, hindi lang installation, fabrication, conducting, hindi lang pagbebenta, pati yung testing and system performance. Air testing and balancing is a process that measures and adjusts the supply of air distribution of a given HVAC system. So the purpose of testing and balancing of an HVAC system is to supply its conditioned zone with a precise amount of supply air required to offset a given heat gain or loss. This process is typically performed after an HVAC system has been installed. The amount of airflow into each zone is determined from the mechanical design plan. Diba, yung mga plano, lalagyan ng airflow. Yung kadalasan dito, hindi nalagay. So, inahati-hati na lang. Pero, mas maganda kung lagyan mo, kung ikaw nag-design, para siguradong pag binalas mo, meron kong laban sa contractor. Diba? Ma-distribute nyo ng maayos yung hangin. Kasi nga, yung mga, diba, yung mga sa bintana, may mga malapit sa bintana, yung sa gitna, iba ang conditions. So the amount of airflow into each zone is determined from mechanical. However, air testing and balancing is also performed in response to certain cases of occupants' thermal discomfort. If occupant thermal discomfort exists in a building with a properly sized and balanced HVAC system, fine-tuning adjustment to supply register may be necessary to satisfy all occupants. Okay? Kung nag-design ka ng uniform flow, so sa actual pala, yung sa living room. So, andun sa isang side yung mga tao, sa iba, daanan lang. So, pwede mo siyang i-adjust to dampers, doon i-concentrate yung hangin. Yung ibig may daanan lang ng tao, wala namang mga tao, hinaan mo. Okay? So, the following testing requirements are recommended. A, room by room, airflow are correct. B, total supply is as designed. So, C, total return plus exhaust is the total supply. D, ducts, plenums, and air outlet are tight, and E, static pressure is correct. Now, balancing the system. Balancing a system involves the following step. A, inspect the complete system, locate all ducts, openings, and dampers. Di ba sa pupunta ka doon, sukatin mo na. Okay? B, open all dampers in the duct and at the grills. C, check the velocities at each outlet. Open dapat yon. Measure the pre-grill area. Okay? Okay, pre-grill area, yung mga, iba yung grills mo, yung mga harang-harang yan. So, tanggalin mo yung, ano mo, yung harang na yon. Okay? Calculate the air volume at each outlet. So, total the cubic feet per minute. Determine the floor areas of each room. Add to the determine total area. Determine the CFM for each room. The area of the room divided by total floor area. Multiply by the CFM equals CFM for the room. So, kung equal ang flow rate, yung ratio mo lang. So, adjust the duct dampers and grill dampers to obtain this value. Yan. Actual na. J, recheck all outlet wheels. In some cases, it may be necessary to overcome excess duct resistance by installing an air duct booster. These are fans used to increase airflow when a duct is too small, too long, or too many elbows. Kasi minsan improper yung design niya. So, testing methods and equipment. Ito. Duct testing. Ang laki naman. Go. Duct testing is the process of using calibrated mechanical equipment to measure the amount of flow that is lost through the duct system when it is at normal operating pressure. While some joints or seams may have only a small leak, other sections may be completely disconnected. Duct testing can indicate the relative leakiness of the ducts and help determine whether the duct system should be sealed, repaired, or renovated. There are two main methods of testing. A. The pressurization subtraction method utilizes a pressurization unit that is a high-powered fan set up in a doorway and connected to pressure gauges. To pressurize first the entire space that is heated and or cooled, and then the same space with duct system blocked off. So this method is less accurate than the duct testing method. Ito yung pressurization mo sa room. Ayan. Okay. So, una, lagyan mo ng pan tapos i-pressurize mo. Tapos then, the same space with the duct system lock off. Yung close naman yung ducting. Okay? So, subtract mo yun. Kuha mo na, malaman mo kung may leak. So, pagka-pressurize mo nun, so, andaran mo lang yung system mo. So, yung duct system mo, block off nung room kasi pressurized din yan. So, malaman mo na kung may leak. B. The duct testing method uses a calibrated pad that gently pressurizes the duct and measures the airflow through the duct to indicate total leakage. The duct tester consists of a portable pan with calibrated digital pressure gauges that is connected at the blower compartment of air handler. So, hindi pa maandar yung talagang blower niya. So, meron kang calibrated pan that is or attached to the main return grill. Yan. Tatap mo sa ducting siya. So, the entire duct register and grills are temporarily sealed and the duct tester pan is turned on to pressurize the system. The pan pressure is read from the gauges and converted to an equivalent duct leakage rate in cubic feet per minute. So if the amount of air loss falls outside acceptable limit, sealing will be required to correct the conditions. So this method of testing is preferred because it measures low airflow accurately and simulates whatever takes place under normal operating conditions. So ito ang gagamitin nyo. Kasi kung sa atin kasi dito sa Bicol, wala pang nagka-testing. Manila lang. Konti-konti pa lang. Kasi meron silang mga equipment na iba takot lang kasi kailangan calibrated. So, airflow measurement, anemometer. The anemometer is a device used to measure the velocity of air traveling through a duct or grill. Readings are measured in feet per minute. Airflow is measured in CFM. Therefore, airflow is equal to velocity CFM times the area in square feet. For example, if mean velocity in a rectangular duct is 12 inches by 24 inches is 1000 feet per minute. Now the volume flow rate is 12 times 24 times 1000 over 144 is 2000 cm. There are three types of anemometer. A. Hot wire anemometer. This has a probe consisting of a very fine short length of wire or small thermistor bead attached to the end of a supporting tube. The wire is heated electrically, and measurements are made of the heat dissipated by wire. The rate of heat dissipation is directly related to the velocity of air passing the wire. Yan. Isang wire lang yan. B is the rotating bed anemometer. So, ito yung nabibili sa, meron to sa, tama, ito yata yun, anemometer sa P. So, this consists of a disc of angled vanes attached to a rotating spindle. It is usually mounted with a protective ring and supporting bracket. The speed at which the vane assembly rotates is a measure of air velocity acting upon it. This speed may be sensed either electronically or by a control mechanism. Diba? Bibili nyo. C. Ultrasonic anemometer. This takes clean air and gas flow velocity measurement with a mini sensor. So using three energized posts, sound waves are transmitted sequentially at 849 times every second. The time taken for sound to travel from one post to another and for a wave to return over the same precise distance is measured. By using the speed of sound at 340.3 meters per second in standard air as a carrier, the true velocity can be calculated with 100% certainty and repeatability. Any changes in ambient temperature, barometer pressure, RS, and gas density conditions are rendered irrelevant for use in mixed air inert gas density situation. So without any need for connection, recalibration, or complex calculation. So manometer. Yan. The manometer is a device used to measure relatively low pressure or commonly pressure devices. Manometer are made into two different styles. Both are used to measure the pressure difference across an object. That is filter, coil, and pan. So yeah. Total pressure minus static pressure is the velocity pressure. Static pressure, total pressures dito. Yan, makukuha mo yan. So, airflow, pag dito ka nagkabit, static pressure. So, ito na, pag ito na maginan mo, lalabas is velocity pressure. Okay? So, A, the YouTube manometer. In order to read the amount of pressure applied, read the value corresponding to the fluid level on one side of the tube and double it. Okay? Incline manometer. In order to read the amount of pressure applied, read the value according to fluid level in the tube. So, fluid mechanics pa yan. So, the Python tube. Hindi ko na-figure dito. Basta Python tube is a device that is usually used together with an incline manometer to measure the static pressure, total velocity, and velocity pressure within a duct system. So this is the Python tube. The Python tube assembly includes a static pressure group, probe, and total pressure probe. A total pressure probe aligned into the airflow senses the duct velocity and static pressure, which equals the total pressure. A static probe aligned at right angle to the airflow senses only static pressure. The difference between the total pressure reading and the static pressure reading is the velocity pressure. This is used for ductworks. Diba? Tutusukin mo yung ducting. Dito, isa doon. Pag ito combined. So now for the airflow at gills, the rotating wheel anemometer is often used for measuring the velocity at inlet grills and stack opening. So if the grills has directional lower, there should be set at right angles before taking the readings. Yung grills kasi open, ano lang yan, di ba namang diffuse. Hindi naman sa diffuser. So pwede mo siyang direktahin yung ginagawa kong instrument na anemometer. Yan. Measurement of air velocity should be made between the blades at a number of positions. So the effective gray outlet area of the gill can be found from the relevant manufacturer's data or estimated from the unobstructed flow area of the grill. Okay? Imagine nyo yan ang grill. So to determine the volume flow, the measurement instrument should be evenly traversed across the entire grill face to determine the arithmetic mean value of the air velocity. So the volume flow is then Q is equal to A, effective outlet area of the grill times B, mean times F. So mean velocity, then the correction factor for obstruction by the measuring instrument. So rotating weight anemometer is 1.3 to 1.9. Okay. Now determine the airflow and duct. So yun nga, yung the pitot tube with manometer, the manometer is generally used for measuring the velocity in the ducts. If you connect the total pressure probe to the high port on the differential pressure sensor and the static pressure probe to the low port on the differential pressure sensor, then the sensor's output will be velocity pressure. So the readings from the manometer are velocity pressure in inches of water column and not velocity feet per minute. Therefore, it is necessary to convert velocity pressure to velocity and feet per minute using the following equation. So velocity in feet per minute is 4005 times Pp exponent 1 half. So where B is the flow velocity in feet per minute and Bp is the velocity pressure measured by the pressure sensor in inches of water column. Now, after obtaining the flow velocity from the equation above, so the value is now multiplied by the duct cross-sectional area to determine the airflow in CFM. So there are two different equations for determining the duct cross-sectional area, one for the round ducts and one for the square or rectangular ducts. So the equation for a round duct is A is equal to pi r squared, where A is equal to duct cross-sectional area. And pi, siyempre 3.14159 o yung pi sa calculator niya, is equal to duct radius in feet. So the equation for square or rectangular duct is A is equal to W times H, where A is equal to duct cross-sectional area, H, duct height and feet, so duct width and feet. Then example, a pitot tube measures velocity of 0.75 to an 80 inches duct diameter. Determine the airflow through the duct. So wait, alisin natin tong pi. So this is an example. A pitot tube measures a velocity pressure of 0.75 inch water column to an 18 inches diameter duct. Determine the airflow through the duct. So calculate airflow velocity is B sub P exponent 1 up to. So the B is equal to 4005 times 0.866 is 3468 feet per minute. So calculate the cross-sectional area of the 18 inch diameter duct. So radius is 18 inches or 1.5 feet, or a diameter or radius is 1.5 over 2 is 0.75 feet. Bakit may point? So velocity, radius, so pi times 0.7 equals 1.77 square feet. So determining the airflow in CFM, so airflow Q is equal to airflow velocity in feet, B times the cross-sectional area. Q is equal to 3468 feet per minute or times 1.77 or 6138 CFM. Now provisions during design for testing and dusting and balancing. So it is important for system air to get to the occupied space with minimal losses caused by leakage and resistance with proper mixing of air without temperature changes from heat gains or heat losses. Also important are the noise, draft, and efficiency with which air is delivered. So this means to meet this requirement are the proper design of ductworks and outlet. So the designer should give special attention to the balancing and adjusting process during the design. It is necessary that the balancing capability be designed into the system initially. Below are some considerations to make when designing duct system. A. Sufficient length of the straight duct must be provided in an accessible area to allow the tub personnel to perform their function properly. This also applies to tub work of the critical branches of the distribution system. B. Mixing boxes should be located on so the discharge ductwork will minimize air turbulence and statification. C. Ductwork to and from air conditioning equipment should be designed carefully so stratified air may be mixed properly before entering past ducts or equipment. D. Adequate size access door should be installed within a normal working distance of all volume damper, fire dampers, pressure reducing valve, reheat coils, mixing boxes, blenders, constant volume regulators, etc. that require adjustment within the ductwork. Kasi kung mag-adjust, kailangan mong maabot yung volume damper. Example, Kung wala, kisame, sarado, so paano mo na-adjust yun? E. Manually operated opposed blade or single blade quadrant type volume damper should be installed in each branch duct takeoff after leaving the main duct to control the amount of air entering or leaving the branch. F. Do not use extractors at branch or main duct takeoff because they can cause turbulence in the main trunk duct, thereby increasing the system total pressure and affecting the performance of other branch outlet steam. Extractors are principally used to divert air to branch duct. So later to. Now we go to duct cleaning. So duct cleaning methods. Methods of duct cleaning vary, although standards have been established by industry association concerned with the air duct cleaning. So typically, a service provider, yung taglinis ng duct, will use specialized tools to dislodge dirt and other debris in ducts, and then vacuum them out with a high-powered vacuum cleaner. Common duct cleaning methods include A. Contact vacuuming, and 2. Air sweeping, and 3. Power brushing. So contact vacuum method, this involves cleaning the interior duct surface by way of existing opening and outlets or, when necessary, through openings cut into the duct. The vacuum unit should only use HEPA high-efficiency particle air collection equipment. Conventional equipment may release extremely fine particles into the atmosphere instead of gathering them. Yung makuha niya lahat ng dumi. Starting at the return side of the system, the vacuum cleaner head is inserted into the suction of the duct to be cleaned at the opening further upstream, and then vacuum cleaner is turned on. Vacuuming proceeds downstream slowly enough to allow the vacuum to pick up all dirt and dust particles. So, contact vacuuming, ito yung sa picture makikita nyo, usually require larger access windows than other methods in order to allow the cleaning equipment to reach into the last corner of the duct. So, access opening. The distance between access hatches depends on hovering equipment and the target distance from the opening. So, the head of the vacuum cleaner is introduced into the duct using the nearest opening at the beginning of the duct network. Hovering then starts, following the direction of airflow and slowly enough to capture and gather all the dirt. So, yan. Kailangan may mga opening. So, karamihan sa atin, wala, di ba? So, kaya paano malilinis yan? So, air sweep method. So, ito. Nozzle na. So, in the air sweep or air washing method, a vacuum collection unit is connected to the downstream end of the duct section. The vacuum unit should use HEPA filtering if it is exhausting into an occupied space. So the isolated section of the duct being cleaned should be subjected to a minimum of 1 inch negative air pressure to draw loosened material into the vacuum collection system. Take care not to collapse the duct. Compressed air, collapse, yung mahila yung ducting mismo. Compressed air is then introduced into the duct to a hose equipped with a skipper nozzle. The nozzle is propelled by compressed air along the inside of the duct. So, yan. Bubugahan mo. For the air washing method to be effective, the compressed air source should be able to produce between 160 and 200 psi air pressure and should have a 20-gallon receiver tank. So, yan sinabi na kung anong size. This method is most effective in cleaning duct network no larger than 24 by 24 inch dimension. Inspection of each duct section and related component is performed to determine whether the duct is clean. So, power or mechanical brushing method. Yan, rotary brush, air or electric, access opening. So, hose to vacuum. Yan. So, direction of work, same as M-flow, papunta ka doon. Binabrush niya tapos binabacuum naman. And the power brushing method, a vacuum collection unit is connected to the duct in the same way as with the air sweep method. Pneumatic or electric rotary brushes are used to dislodge dirt and dust particle. Malambot to Brushing operation will usually require larger access opening than the previous method. Nevertheless, fewer openings are needed. Certain mechanical certain types of mechanical brushes can reach up to 24 feet in both directions. So, inspection of each duct section and related component is performed to determine if the duct is clean. When the section of the duct is clean, the brush is removed from the duct and inserted through the next opening where the process continues. Other cleaning variations. So the service provider may propose applying chemical biocides designed to kill microbiological contaminants to the inside of the work and to other system components. Some service provider may also suggest applying chemical treatments, sealants to encapsulate or cover the inside surfaces of the air ducts and equipment housing because they believe it will control mold growth or prevent the release of dirt particles or fibers from duct. These practices have yet to be fully researched, and you should be fully informed before deciding to permit the use of biocides or chemical treatment in your air duct. Coordination between design specialties. The process of design review includes a spot check to verify that the mechanical design is coordinated with electrical, structural, and architectural design. Many of the following coordination checks will ensure energy efficiency in addition to verifying system integration. A. Is the structural support adequate in the areas where mechanical equipment will be located? B. Do the architectural and structural detail provide the necessary sound isolation and moisture protection in the mechanical areas? C. Are the intake and exhaust penetration through the walls adequately sized to prevent high pressure drop and moisture penetration? D. Are the chassis large enough to allow adequate size ductwork? I think this is other topics too. So, wait. E. Are the structural clearances around chassis and other areas with large tank and piping mains sufficient to allow the system to be installed without high pressure drop? So, di ka yung malaki yung duct mo kasya. Di ka mapilitan na paliitin. So F, is there a sufficient space above the ceiling and below the structure to allow the necessary mechanical system to be routed in conjunction with electrical, plumbing, and specialty system without an excessive number of offset and or restricted duct sizes. So, maluwag ang area mo sa kisame. Papalagay ng ducting, wala namang daanan sa kisame. So, wala. Letter G, have general rules being established for routing ducts, pipes, conduit, and specialty system through the ceiling cavity. If so, do they meet the requirements of the mechanical system? H, is there a suitable access route to allow worn-out equipment to be removed and new equipment to be installed? Servicing. Does this route contain adequate structural strength to support the equipment that might be moved through it? So, wala yan dito yata. So I, are the electrical service requirement coordinated with the requirements of the mechanical system in terms of voltage, capacity, reliability, and source? Ito meron. An air handling system that has its fan powered by the emergency system, its direct digital control, DDC, controller powered by an UPS or uninterruptible power supply with an interlock circuit on a normal power may experience a few problems when there is a momentary power source on the utility line. G. If the project will use variable speed drive, who will specify them? If the drives require isolation transformer or line reactors, who is responsible for sizing and specifying them? Okay. Have the motor's power requirement changed since design development? Okay. Kasi pag design, magre-reference ka na sa available mong data na horsepower. Minsan pag nasa installation na, so construction na, yung mga supplier nag-offer sila ng minsan mas mataas ang motor. So kailangan i-check mo. Pag di siya pina-check, so yun, mangyayari talaga yung electrical apektado. Pag di siya pina-check, yung motor niya oversize. Hindi mo ma-monitor. Okay? Kasi nga yung parang sa pump o sa pan, that is CFM and the static pressure ang kailangan mo para makuha mo yung fan motor. Okay? So sa fan motor, 1.5 nakuha mo is 1.5 horsepower, so pwede sila mag-offer ng 2 horsepower. Okay. So 1, has the type of starter will be used for large machinery being coordinated with electrical designer? Often changing the type of starter or the voltage that is used to serve a large motor can improve electrical system performance and reduce first cost. So these coordination issues have ripple effect with significant implication for energy and resource conservation. For example, if a coordination problem between a mechanical system and a structural element is not resolved at design stage, the field solution may require additional fitting. This fitting will introduce pressure drop that will persist for the life of the system or possibly the life of the building. As another example, consider an equipment room with a poor access road. The lack of suitable access may delay the replacement of an existing outdated piece of equipment with a more efficient machine, simply because the cost to bring the new equipment into the building is too high. Hanap ka ng lota kasi karamihan ng building dito yung mga machine room maliliit. Okay. Next, general rules for duct design. So A, air should be conveyed as directly as possible to save space, power, and material. B, sudden changes in direction should be avoided. When not possible to avoid sudden changes, turning pins should be used to reduce pressure loss. C, diverging sections should be gradual. Angle of divergence should be less than or equal to 20 degrees. Aspect ratio D should be as close as to 1.0 as possible. Normally, it should not exceed 4. Ito yung ratio ng width ng duct sa height ng duct. So, air velocity should be within permissible limit to reduce noise and vibration. F duct material should be as smooth as possible to reduce frictional losses. Round duct require 27% less metal per unit of air handling capacity than rectangular duct and have lower installation costs, which may result in substantial capital cost saving. H. Rectangular metal ducts are the most flexible when it comes to fitting them within limited space and are used in many duct systems with pressures under 2-inch water column, particularly when the installing constructor has a sheet metal shop. I. Leaks with medium and high pressure system can create considerable noise. Sealing materials include gaskets, pressure sensitive tapes, embedded fabrics, mastic, and liquid. So, yan. Rules for design ng ducting. Okay, so ito yung sample ng layout. Ito yung mga diffusers, flexible, at 1.5 meters dapat yan. So, ito yung mga branching. So, ito yung supply. Ito yung return. Return is open yung ceiling mo, ceiling. So, papasok ito sa mga, ito yung mga return mo, return grills mo. Papasok ka dyan, then pasok dito. Kahit di ka na mag-ducting. Pero kung may harang dyan, so magdadacting ka. Okay? Ito pa. Ito yung mga flexible. Ito yung diffuser dito, linear. So, ito kasi may drop ceiling. Okay? May design. So, dito ka maglalagay. Diba? Supply, return. Then, ito pa yung isa. Ganun din. Mga supply. Isang return. So, supply din dito. Yan. So, ito yung unit mo. Okay? Ang return niya, so, andito na sa likod. So, ito naman, rooftop package unit. Ito yung rooftop, top view. So, ito yung fresh air. Pasok dito. Ito pala yung supply. Then, pasok dito. Then, may access door. Paglinis niya. Kasi malapit ka sa elbow. Yan. Dito. Karamihan to. Pag rooftop package unit na. Andiyan na yung condenser mo. Ito na yung evaporator. So, ito yan. So, ito yung concrete base. So, ito na yung inside ng duct mo. Yan yung unit. Pasok doon. Circle na. Round duct yan. Round duct. Yung iba, di mo makikita kasi nasa loob ng kisame. So, okay? So, ito naman yung typical installation ng ducting. May hanger, insulation, air duct. Yan yung mga, ito yung sa detail, nalagyan mo kung ano yung mga materials. Okay? So, ito naman round duct. Fittings. Ang fittings sa elbow boot, reducer. Ayan, mga fittings na yan. So, dito yung mga equivalent length. So, rectangular duct, equivalent length, andito rin. So, kung marunong kang gamitin to, so okay. Yung mga fittings niya, di ba? Ayan, allowed fittings. So, ito naman is na low pressure. Ito yung may BAB. Ayan. BAB box. Ito yung duct. Pagkabot dito, may isang BAB box. Minsan mayroong reheat yan. Ito sa BAB box, may blower. So, ini-increase na yung pressure. Okay? Ito yung local ductwork. Para maliit yung ducting mo. Ito yung variable air volume. Nagbabago yung volume niya. Ito. Next, ito yung common symbol sa ducting. Yan, pag nag-drawing kayo, so itong gagamitin nyo. Symbols. Ito pa. So, yan, mga symbols din yan. Okay? So, this is the end of, ito pala yung ducting. Insulation na siya. Ito yung mga staple yan. Dumikit yung ductwork, tapos palutan mo ng foil. Ito yung mga hanger. Rod. Okay? So, this is the end of air conditioning topic.